This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
So welcome, I'm Leigh Bortons. It's Wednesday, May 22nd, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. We're currently in our summer session and working through the curriculum by dimension rather than by lesson, so we can discuss strategies and resources in a broader context in math education. So Kirsty, what do you have for us today?
Well, we are just rocketing through since we're going by dimension. So today we are going to be looking at some of our lessons in 3D, and it's going to feel, I think, a little bit familiar to those who were here with us last week or who have watched the recording from last week, because we're going to continue to talk about the skills of learning that we're focusing on throughout these trivium years, and how we can use those with multiple domains to understand one working together or using a different domain, but also specifically this week looking at how they relate to some problem solving strategies and techniques we may see in other math curricula. So we always like to start off by checking in on our math map. And so as you can see here, we're looking at lessons 19 through 22, and we're going to be pulling some examples from naturals, fractions, and complex. And before we jump in to this week's conversation, what questions do you guys have? Did anybody come prepared with a question today that they'd like to ask? So we just want to remind you that this time is although we've come prepared with some things to discuss, our goal really is over the summer for you to feel empowered and welcome to ask your questions. So whether they're from things we talk about today or things that you're looking at home, feel free to bring those questions, because we're going to make sure that we have time at the beginning and the end of the calls for your questions. This is your chance to really ask us anything you want to know about the math map or about the math. And so I just encourage you, as you're looking through the materials at home, to take advantage of that.
I know at Practicum this weekend, I was able to do two in the last week. And one of the bigger questions was the upper challenge, being up. How can we use this? How can we use it in class? We want to do something. And just to give a clear answer from y'all, what exactly can they use? Can't they use? What do y'all recommend for that in their classes, maybe for an exordium or something like that?
Leigh, do you want me to answer that, or do you want to chime in?
Sure, you can answer it.
Sure. So we always want to really honor the licensing agreements that our directors are signing and the programs that we have offered to parents. And so for Challenge B through Challenge 4 for this coming academic year, and then that will shift in subsequent years, our directors are licensed to lead their class through the appropriate guide, which is going to be using the Saxon materials. So that is what licensed to do, and that is what parents are expecting. That is the program that we have given them. Now, within that, and that there are a lot of people who are excited to dive in and use the math map with their older students. In community, they're still going to be working through Saxon, and that best conversation is going to come, just like we keep saying with the math map, right? The best conversation is going to come when everybody is working through the same lessons at home. That's where those conversations are going to be the richest. Now, a director may want to pull in some of the covers to use as their exordium. So they could look at some of the covers and maybe see where they line up or just walk through lessons 1 through 30 and bring that in as an exordium. Families may choose to incorporate some elements of the math map at home. Certainly the notations flashcards, all of the flashcards, but the notations flashcards are going to be especially helpful for older students who maybe are still working on the language of mathematics. Understanding where the topics that they're looking at in the Saxon curriculum fit on the math map will be helpful in them being able to see how that picture of mathematics fits together. And so certainly working through some of those elements at home are going to be helpful. We have had families who have used the complex material with older students and have said exactly that it's taken all of the work that they've been doing and it puts it into a framework where they now are starting to make those connections. But we don't want to undermine the challenge guides and all the work that has gone into preparing a great year for Challenge B through Challenge 4. So we're really encouraging everybody to take advantage of that guide. And I know sometimes it's hard to feel like you've missed out if you're just on the other side of this transition. But that's right now, that's what we believe is the best path forward for everybody, is just honoring the guide and what they have, but bringing in some of those elements for the exordia.
One thing also to remind parents is that we just meet 30 weeks a year. You could be having your children run through the naturals or the fractions this summer or next summer in order to not miss out on the actual map and getting prepared for when we do roll it forward for other, grade levels. And then something one of the SRs have pointed out to me is that we've put so much time and attention into the Challenge A directors and tutors to be sure they are really well equipped. And we don't want someone who's well-meaning and say Challenge 1 or Challenge 2 working forward and then maybe giving that community a bad taste because we haven't been able to give them the training they need. So this is a big endeavor and it's brand new. And it's so exciting to hear people wanting to do more. So we're asking you to kind of do it out of community.
Does that help, Donna?
Yes, very similar to what I've been telling. A shorter answer, but
yeah.
Thank you.
Thank you. All right. So this week, as I said, we're going to continue with some of the similar themes as we looked at last week, but we're going to specifically look at it from a perspective of problem solving. In lesson 22, and I put some pieces of the charts from lesson 22 into our slide for those of you who maybe haven't seen the charts yet. In lesson 22, the first 3 pages of the charts are dedicated to looking at our skills of learning, our core habits, our common topics, and our canons of rhetoric, and seeing how do they inform our study of mathematics. And so on this page here, which is the first page of the charts for 22, you see one of the very first things that we do. I'm going to highlight this because we keep saying this. Read the problem completely. And so that is the very most important thing when we are working through the math map, is always reading that. If you don't read the instructions or read the problem completely, right, we keep saying you're probably going to think you're supposed to do more than you need to. And that's when it may become overwhelming. But when we look at reading a problem, and I'm using problem here because we often talk about exercises because we know that we make all those jokes about math problems. But when we're comparing this to like word problems or problem solving techniques, problem is the appropriate word. So when we're given a problem, we want to read it completely. And a lot of what we're talking about here may be focusing on word problems because there's usually more information there to sift through. but it's equally appropriate to use these skills no matter what the exercise is that we're working through. We want to read it completely first. And some of the questions that we want to be asking ourselves that we're going to be able to use the core habits to help us answer are: what are the parts? What's the question? What do I need to know? And what should my solution look like? And so that's, as we look at this portion of the chart here, that's what these questions, using these core habits, are going to try and help us to first decode what is my problem that I'm working through. Because if I, again, right, if we just jump through that, we oftentimes can end up answering a different question than the one that's being asked. So let's go ahead and take a look. This is from lesson 20, and it's page 1 of lesson 20. And so I've got the 3 levels here so you can see how they are building on one another. And let's work through this together. So one of the things I said, we want to know what are the parts. So we may look at our exercise here, our problem here, and think, well, what can I name? So what are some things that we could name on these?
You can name the faces and you
Or
name
the numbers of them.
the number.
Mhm.
You can name the vertices.
Mhm. Edges. The type of polyhedron it is.
Good.
And then on the far right, we can even name whether it follows the Euler's formula of faces plus vertices minus edges equals 2. And what's that tell us, Kirsty, that it's actually a regular polyhedron?
That's actually true for all of our polyhedra.
Regular or irregular, okay. So also, before you go on after this page, Kirsty, we've had a couple questions I need your help answering, so I just want to let
Okay.
you know, but finish this one first.
Okay, so right away we see that we're actually instructed to name, right? So naming the shape, and then talking about, okay, what are the faces, the vertices, and the edges? That's great. So what is the question that we're being asked? And this is a great place to attend because it's somewhat an implied here. So if our students look at this, what question are they supposed to be answering?
Maybe what are the characteristics of an octahedron?
So we are looking at the characteristics of the octahedron. But what am I putting in those blanks? So the name, right? You just said, okay, so I've named, what is the name? It's octahedron. What kind of answers am I expecting to put next to faces, vertices, and edges?
Numbers?
Numbers. And what are those numbers going to be representing?
How many faces, how many vertices, how many edges?
How many, right? So we had to really attend to that because it doesn't say list the numbers of. And so we need to kind of attend and pay attention to this and in order to even figure that out, what we have to do.
This is a good example too, because there's, except for the complex addition and subtraction problem, it's just the language of math and descriptors of mathematical shapes.
Yep. So then when I'm looking at this, right? So again, the next thing before I started to do anything, right? I've now said, okay, I can name some of these things. I know what it is that I'm supposed to do, right? What I'm attending to, what the question is. In order to answer, what do I need to know? What have I memorized?
Hmm.
I might need to know what is a face, what is a vertex, or what are vertices, right? So there's a case where I have to know both the singular and the plural. What is an edge? So those are some things that I may have memorized in order to be able to answer this. may have memorized the numbers that go along with this, right? If they've been in the math map for several, they may recognize this as one of our platonic solids and they already know that information, or they may go ahead and just count, right? And so we could have counted those as well. And then our last question that I had for us is what should my solution look like? And in this case, we may just be writing a number, but this is a great time to ask a student, right? How could expressing or storytelling help them to communicate the answer? Right? Especially if we were dealing with a word problem, right? If I have my problem or my exercise that it's expressed words, then I probably want to use words in order to express my answer. Right? And so here, what are my solutions going to look like? Am I going to use expressing or storytelling? Or somebody already said, I'm probably just going to use numbers. Right? So we want to help our students know what is it that we're expecting, right, for this. But could they put this together into a little narrative? It's not necessarily going to be a full story, but how could a student write a narrative using the information on this for this exercise?
We talked about my shape's called a polyhedron. And it's got 8 faces, or 8 edges, or 8 vertices. Sorry, it's only got the wrong number, but it's got 8 anyway, 8 faces. I know that's for sure. I'm going too fast. So it's got 8 vertices, and octa and 8 go together, and that reminds me of octopus.
That's great, right? So we could make a narrative, putting that in there, that doesn't necessarily have all the elements of a story, but encouraging our students, maybe not with every problem, right? Not every exercise do we need to do that. But here's a case where helping them to verbalize that and read that back to you is going to help build that memoria and help build that understanding. So there's a case where we've just used our core habits to work through these, and notice that we can still use those really in any of these domains. And we're gradually adding more information to these domains. So for our youngest students, they're just tracing and coloring, but we as parents could read to them that that's octahedron. And at that point, we're probably building their memoria. So they're maybe memorizing that an octahedron has 8 faces, whereas our fractions and complex students maybe are making that transition to where that's something they've already memorized, that they're pulling in. All right, so let me find.
Well, one question I couldn't answer was somebody wanted to know where a testimony was kept, and I didn't even know what the testimony they were referring to was. So does that person want to explain more?
She answered that. She gave the testimony out.
So they're answered already? Then this other one's from Melba. So Melba, it's a great question. Is there an errata sheet for the domain for digitals? No, there is not. There definitely is one though for complex. And so these errata that you have pointed out, we'll keep track of them and go ahead and make sure they're corrected in the naturals. It's being all cleaned up right now for sale. And then was there, Melba, did you have another question? I saw your hand raised at one point.
No, that was it.
Okay.
Thank you.
Mm-hmm. And I don't know, Babs, you seem to be answering, and Donna, were there any other ones?
I think they all got answered in some way.
Looks like it's me too.
All right.
Thank you.
So there are our core habits. So now, and I'm just going to point out that going back here, that we know that there's our 5 canons of rhetoric, right? And our first canon here, Memoria, was on our first page. And a lot of times that memorizing gets wrapped up into that Memoria. Although I like to think of the difference between the two is that memorizing is usually when I need it to be exact. So I would memorize that C equals 2 pi r, right? Or that circumference is 2 times pi times the radius. That's an exact thing that I'm going to memorize. But if I had, but my Memoria may be broader or less exact. So it may be that the circumference is the distance around a circle, right? It might be something I've memorized, but I may use different words than a specific definition. And so it's a little bit, I don't want to say looser in the terms of it doesn't matter. We use and the word order we use might be a little bit different. So there's a lot of things that need to go into our memoria, but aren't necessarily memorized. And from that, right, so our memoria is broader. It's going to include the things that we've memorized, like the addition and subtraction facts, multiplication and division facts, trig ratios, rational approximations, right? So there's lots of numerical facts. Then there's all kinds of terms and relationships, like our domains and our dimensions, our laws, our terms. Those are all in our memoria. And then also on that chart is we have a lot of keywords. So especially when we're thinking of word problems, being familiar with the words and knowing what symbol or operation goes with those words helps us. And so there's a whole list of those on that chart to help us build that memoria of those words and how they relate. So that's our first canon of rhetoric. So I just wanted to point that out because now, as we look at this one, we're going to look at our second canon of rhetoric, which is invention, right? And a lot of times when we think of invention, we're looking at the common topics to help us draw that information out. And so this is a picture from the second page of the charts for lesson 22. And I wanted to point this out because we have on here these terms, and these are terms that are commonly seen. If you were to look at another math curriculum, these are some common ideas that are presented to students in order to help them solve problems, right? They're problem solving strategies. And so we wanted to help connect those to our common topics to help you see that these common topics are going to be giving you a similar approach to problem solving, but then broader. So when we're thinking about problem solving classically, where we started off by reading our problem and saying, what is it that I need to know and attend to, right? Here, I'm going a little bit deeper. So now not just can I name things, can I read the words, but what do the words mean, right? I might be wanting to know, what is it that I need to compute, right? Is there some kind of computation that I need to do? Or is this a really complicated problem that's got multiple steps to it? Or is there a way that I could simplify the problem? In that we could also say, right, breaking pieces, breaking a problem apart. So that's where we're thinking of relationship questions, right? Looking at order of operations and doing side work and so forth. Then when we think of circumstance, we can think of, is there more information than I need, right? What are the circumstances, and can I ignore some of those? And we all know that a lot of texts, that's a really common strategy, that there's sort of red herrings popped in there for students to think, oh, I need to use that, when sometimes it's just extra information that's not needed in order to answer the question. What patterns do I see? And then what could I act out, right? So that's that idea of movement. So for example, when we think of combinations and permutations, that's a great place to act things out, because I could take my teddy bears, right? And I could say, okay, how many ways can I arrange my teddy? Actually have my students take and put my teddy bears in different orders, right? To start to see how those things go together. So we're taking the concrete to connect it to the abstract. So that's what move means. And then I didn't put this on the side, but that idea of testimony, right? What laws or properties, right? Can I look at the answer key? We've talked about being able to work backwards. Guessing and checking, right? Those are another strategy when I'm not sure what it is that I'm trying to do in a problem, that guessing and checking, right? Is this a possible solution? Does that make sense? And then can I refine it? So taking those problem solving techniques, putting them in context of our common topics is one of our goals for this chart. So let's go ahead and take a look at that with another problem, and this is from lesson 19. And so let's again ask that very broad question of what do I know or what do I need to know in order to solve these here. And so as I look at these, what are some things that I could define? So if I wanted to look at this, these examples here, what are some things I might want to define?
What those letters or symbols mean in the naturals?
Mhm.
Well, I guess in all of them.
Mhm.
It's great.
Yeah.
But you don't have to know them to copy them for fractions and naturals.
And what the P stands for on the globe, and yeah, that's interesting.
Mhm. That's good.
I would also point out that that's not a circle, that's the globe, so it's a sphere,
Mm.
Good.
which is hard to see on a 2D piece of paper, but
That's good.
Is it phi or phi? It's phi for the how you
People say it both ways. Most commonly it's phi, but people both ways.
One thing to note here is it's not P equals R theta phi. It's P next to R theta phi. So that's the designation for a point versus a value.
so noting that it is in parentheses and there are commas, not plus, minus, you're not doing an equation. It's a series of numbers, not necessarily something you're computing.
Right. Good.
They're coordinates, right?
They are coordinates.
And you don't see so much about how their coordinates and naturals and fractions. We do actually show them some on some easier problems. But over in a complex, we begin to expect you to start to recognize how to read them in one octant of the polyhedron.
So what could I compare on here?
You mean between the levels?
Well, you could compare between the levels if you have multiple students, or if you just are looking in one of these, right? When I copy, let's look at just naturals. What would I be comparing top to bottom?
The letters in their placement?
Right, the placement is right. So if I'm copying that, I want to make sure that my R, right, is first, my theta is second, and my phi is third, right? So I could be comparing their placement. How about if I had a student who was in fractions, what might I compare?
Well, besides the same thing, you could look at that 4,600 meters and wonder, why is that there? Or maybe notice, I wonder if it's R, and I don't know what R is, but it might be the distance from something because it's in meters. That might be as far as you get.
And like the
You can
X,
see. Go
I'm
ahead.
sorry. I just was thinking the X, Y, and Z, do they compare to?
Good.
Good. So something you know that's not on the page.
Yeah.
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 So for this problem, the R and the theta would be the X and the Y place, and then the phi would be the Z place, or no?
There'd be one-to-one correspondence, but they mean different things.
And I was going to say
they
that
are
you can
related.
see that the R in 4,600 meters, that the R is 4,600 meters and theta is 0 degrees and phi is 0 degrees.
Good. And then how about in complex? What might we be comparing?
That one's a little harder, so you got to really attend to make the comparisons.
I mean, for me, not really knowing this, but seeing the polar coordinates, I'm used to Y being straight up and X So
Mhm.
the x-axis is the same, familiar. The z-axis going up is unfamiliar because I'm used to it being y.
Good.
I'm seeing like the different angles of the phi, of the different symbols, the theta, the phi, and whatever p is.
Good. So we could match on the right-hand side. We can compare that 4, 45, 30 to our diagram, right? Could we find the 4 and see that that's measuring a distance? And the 45 and the theta are both measuring an angle, right? In this case from X. And my 30 matches up over here to my phi equals theta. And it's an angle, but this angle is coming off of my Z. So I'm starting through comparison to notice what these things maybe mean. Right? I may not be all the way there to understanding it, but I can see, right? I can start making that comparison.
Is
Look
there,
at it.
I'm just curious, are there any of you that look at the complex and couldn't do that? Look at the image and just write the numbers next to the R equal, theta equal, phi equal? And if that is hard, why? Help me understand so that I can do better.
Mostly just because a little bit of it is unfamiliar, but when I start putting the pieces together between the naturals and the the middle level, then I'm able to do the complex a little bit easier. I don't know if that answers what you're asking.
And the other thing is, remember, Kirsty's showing you half of the page. The problem to the side of it gives you more information on how to do the problem. So this is really out of context, and yet still most of us can at least answer R, theta, and phi, which is all you're being asked to do.
I like that I can trust that you're gonna always include that degree sign. So it's not gonna be hidden. So I can see that there's a difference between R. I don't know exactly what it is, but there's a difference between the 4 and the degrees of 45 and 30. So I already know there's a difference because you already always include those things for me. So I think that actually helped me a lot.
Well, pray that's clear, Amy, because there's a lot of little degree symbols we've been keeping track of in writing this. What does it do to help you compare the 4 on the complex to the 4600 M on the fractions? Does that tell you anything?
Tells
Yeah.
me the complex is a lot shorter.
Yeah.
And there's no actual unit of measurement in the complex one, whereas we have the unit of measurement for the North Pole for the other one.
We don't really know if it's shorter or farther because it could have been 4 kilometers,
Oh,
right?
that's good.
So
So that's why units matter so much.
Isn't degrees a unit of measurement though too?
it is
R doesn't have a unit of measurement.
correct.
Yeah, when there's not a unit of measurement, you just kind of assume that it means R units, and we don't know what they are exactly. And mathematicians in our laziness just don't write the word UNITS after everything. But, so getting your children to recognize that. So on the problem on the left, or the fractions, we put the measurement in, and whenever we ask the students for a measurement, we give them measurements, because that would be unfair to do.
So how about looking at these and is there any kind of relationship that seems to exist, or how might the circumstances change the problem?
Do you mean like if the P moves, then it changes the circumstance because it moved from one point on the globe to another point in the middle section?
Okay, good.
Yeah, if the P moved from where it is to maybe, the Carolinas or somewhere in the US, what of those would change? And I'd be interested to see a comparison. My guess is the R's not changing, but the 2 degrees will.
Good.
Would a relationship be for the complex graphic, like the taking 90 degrees minus 45 minus 30 to find the shaded area, or do we not, is 90 not given to us? It looks 90, but maybe
It-
that's not right.
It would be a 90-degree angle, but it's hard. So this is just one of those examples of where this is really hard to draw a picture of a 3D polar graph and help, right? So we really worked hard on these images, but that 45 is being measured in this plane here, right? My flat plane. My 30 is actually being measured from here, right? So there are two different planes of measurement, and then that radius equals 4. If you could think of there being a sphere, right, that would go at radius equals 4, and then we're sort of trying to find where all of these pieces intersect. But that's a great question, right? So when we say what's the relationship between these, right? Well, in order to find one point in 3D, how many pieces of information do I need? I need all 3 pieces of information, right? I can't just, if I only knew any 2 of those, I wouldn't be able to say, oh, just this one point. I need 3, right?
Yes, if you have 3 dimensions, you need 3. 2 dimensions, you need 2. 4 dimensions, you need 4. But Donna's asked a good question that you can see comparatively here. I'm sorry if you were going to go there, Kirsty. But if you look at the naturals, there's no axes drawn. And this is a way that we're grading and adding more information. When you get to the fractions, we've put in the X, Y, Z, and there's a conflict there. And we showed examples for all these. X, Y, Z is a rectangular coordinate, yet a sphere is a round shape. Well, they do have a relationship, and you can put them on a rectangular coordinate system. But on this final one on the far right, we're looking at polar coordinates in just one octant. And so we only give you the information that you need there. And polar coordinates also are drawn a little differently than rectangular coordinates are. So you can't see that. All that information I just gave you is across all the curriculum through, not just in week 19, but in week 19, you see all the various examples of how you could draw a picture, but Kirsty's just picked one to have you compare. There's lots of them.
Could there be, like, on that third one? I think that really helped me that you said it's 3-dimensional, like that bottom line of the triangle, is that Y?
No, this,
Oh,
so
I'm
let
sorry.
me,
I'm probably not doing this correct. I'm
No,
just,
so this here
yeah,
is,
what is
is
that?
this is this angle, right? So when I measure 45 degrees in this plane, right, in this horizontal plane, that's where I get to. Then let me change my highlighter color here. Nope. Highlighter.
while she's doing that, remember, if that was the Y-axis and the X-axis, we would have had to write 90 degrees.
Oh,
Then
yes.
here's my next angle.
Okay.
Right? That's 30 degrees. And so I'm measuring that. So picture, if you could picture now, I took my first angle and I've sliced it. So I've kind of said, there's this plane that happened at 45 degrees, but now I'm going to slice down and I'm only going to look at the points that are both 45 degrees from X and 30 degrees from Y. So that would be this line here. And then I say, but now I only want the ones that are at 4 units away from my origin, right? And there's my point.
Wow.
Right? So there's a relationship, right? What order did I? Well, I first went right in my horizontal. Now I'm going to say, okay, I only want the ones that are 30 degrees down, and now I only want that one that's 4 units out.
Wow, that's cool. Thank you.
And Amy, I'm appreciating that you saying wow, and even that it's that's cool. But this is once again why analytical geometry and calculus begin to be so difficult for us, because we haven't spent the time understanding how you draw 3D ideas on a 2D piece of paper.
Yes.
And then
Yes,
you try to add a problem to it and you wonder why we're all frustrated.
yes. It would be nice if it was this dynamic with like Kirsty doing the.
Oh, it'll be that way one day, I'm sure.
Yeah, that's good. Thank you.
All right, so one last question that we be asking, right? Are there any laws that apply here? And it's okay to say, no, I'm not, there's no big laws necessarily. Maybe everything that I've done was definition or comparison relationships, right? We don't necessarily have to ask every common topic question every time or answer every common topic question every time. But when we look at this, is there any law or authority that somebody goes, oh, well, I see an example of that here?
I would
mean,
imagine
somebody-
that pattern,
Go ahead, Donna.
the pattern of, how many points you need, how many references you need is a law of sorts.
Okay.
So it is, it's not one that we've memorized or we know yet, but it is a law of sorts.
Sometimes in math, it's more, there are definitely laws, there's a lot of them, but sometimes it's more convention. Like y is y to the left of x. And it could be we wrote our curriculum totally another way, but then we would have had to explain the convention that other mathematicians aren't using. And so the authority is, in one way, is what's the standard?
Good. So Leigh, I like that you said that, right? Just because that order of R, theta, phi is a convention, it's not necessarily a law, right? It's not some universal law, but it has become accepted convention that we always write our variables, our coordinates in that order. And so if Leigh had said, well, I'm just smarter than every other mathematician and I'm going to change the order, she could have done that and we could have defined that for the math map. But then if we went to another math curriculum or went somewhere else, we'd be talking a different language. And so there's a lot of things where the question might be, well, why is it in that order? Well, because that's how we all do it. That's how we all communicate, right? Polar coordinates in 3D is in that order. Just like if we look out and I said, that's a pine tree, because we all agree that pine tree represents that kind of tree, right? And so I like that you brought that up, Leigh, because one of the things that we noticed in 2D, for example, is usually when we write our coordinates, we have our independent followed by our dependent coordinates. But for polar coordinates, they're flipped. It's our dependent followed by our independent. And if you Google it, people will be like, I don't know why, but that's how it is, right? And it might make sense to flip it back around, but since nobody does that, right, it would just be really confusing. And so some of those conventions just end up, right, becoming the authority so that we can communicate with one another.
I just caught an error. It's not 4,600 meters. It's from the equator, it would be 4,600 miles. We needed an I there. So it would be correct if I had told you I was coming from, oh, I don't know, Canada.
It should be the center of the Earth, right? The radius of the Earth. So I don't know what
Okay. Well, then that was my mistake. So if you do go through the radius, that's what it would be.
Yeah.
I thought it was going to go this way around.
No, that first point is always from our center, right? It's not the circumference or the outer part, but from the center of our sphere.
Yep.
Which is why, as Donna pointed out, usually when we're thinking about the surface of the Earth, right, we know that the radius of the Earth changes, that the Earth isn't a perfect sphere. We've got mountains and trenches and so forth. But usually we think of the surface of the Earth as being our 0 point. And that's why most of our maps are in 2D, right? Unless you go and buy a topographical map, right now you have 3 coordinates because I'm showing those elevation changes. But like road maps, we don't show all those elevation changes because you don't really go up and down, right? You're just staying on the surface. And so that's why most of our navigational maps are 2-dimensional, because we just sort of assume, right? This 0 point, this constant radius. All right, so the last piece of information that when we're looking at things, or our last of our skills, are our canons of rhetoric. And we've talked about Memoria, and now we've talked about Invention, figuring out what I know and what I don't know. And then our last 3 canons of rhetoric are arrangement, elocution, and delivery. So when we think of arrangement, and I just realized that I didn't really actually pull in good arrangement questions. I must have gotten stuck on my preparation for today and thought I was finished, so I will apologize. So we're going to talk about it using what's here. But there's 2 ways that I can think about arrangement. One, how can I arrange my information in order to help me see patterns in what I'm working on? Right? How could I arrange my information to help me see those patterns? The other thing that I can do with arrangements is how could I arrange information to help me communicate my ideas? And so as you can see on our chart here, there's lots of different ways that we're giving, but there's lots more, right? There's different ways that we can arrange things, but we can use tables, and we can use tree diagrams, we can use Venn diagrams and Euler diagrams, all of these different ways of arranging our information so that I can determine, right, what patterns that I'm seeing, so that I can communicate that to somebody else. And so even though what I'm going to show you on the next slide is just right, I didn't finish it. My daughter was having her wisdom teeth out yet, so I'm going to blame it on that. But
you're doing great, Kirsty. It's a lot. Don't worry.
But we'll talk about that idea of arrangement, right? Is really what we're talking about, the order, right? That things were in is both relationship, but it's also arrangement, right? That how those things are arranged is communicating. And we think of elocution, right? When we think of writing a paper, we're oftentimes thinking of style, right? We are not always going to be very stylistic in our math, right? We don't necessarily think about writing with a flourish, or being cute, or adding lots of adverbs to our math. But what have we just talked about that belongs in our solutions?
All your steps.
So it might be my steps.
Is it clarity? Like you want to make sure you're writing, that you can read what you just read.
Sure.
Okay.
I'm gonna come back to that idea when we're talking about delivery. What did we talk about when we were looking at the fractions compared to when we talked about fractions compared to the complex, what did the fractions have?
You mean less math language, or less math notation?
The units.
The units.
Okay.
Right? So that may not feel like it's a style, right? But when I think of elocution, what are the things I want to know? Am I answering the question that was asked, right? Did I use the proper units, right? So with elocution, with our, right, I want to really answer the question, right? Do my units match? Do my, right, again, how many dimensions should I see?
Well,
Three
three
dimensions, right? There's 3 dimensions. So if I had done something like this, if I had copied this and I'd said, oh, this was R and this was theta, and I didn't put phi in, do I have the same number of dimensions? No. So those elocution questions are, hey, do my dimensions match? Do the domains match? Right? So if my answer is in natural numbers, and I tell you to put your answer in a natural number, but you give me a rational number that's not natural, right? Now my domains don't match. So I want to look, do my mid dimensions match? Do my domains match? Do my units match? Did I answer the question? And I think those are things that we talk about but we maybe didn't think of them as being elocution. But that's, oops, sorry. That's what we're thinking about when we think about elocution in math. And then, and you're right, when we deliver our work to somebody, right? What are the things my solution, right? So we talked about, did I show my work? Is it neat and logical? Right? I'm sure we've all had students where some, right, there's like pieces of all over the paper, right? Is that a good delivery? No, right? So helping them, right? We want to make it so that we can clearly see what was the process that they followed. All right.
Good. So Nicole has a question that I'm not understanding. Do you mind going back to the page before, Kirsty?
This
And
one here?
yeah, she's asking about the angle measure. So go ahead, Nicole, explain what you're
No.
asking.
Oh, hold on. Well, we weren't necessarily trying to solve for the unknown angle, but what I do remember is that the opposite angle for 30 and 45 degrees is exactly the same on the other side, and half of a sphere is 180 degrees, or half of a two-dimensional circle, I guess, is 180 degrees. And so if you add those together, or take away, you've got 180, take away 75 degrees, and you're left with 105 degree angles, which leaves, oh wait,
So
I didn't follow that through all the way, actually.
sure, yeah. So these angles cannot be, you can't add them because they're in different planes. So so I have this angle here is 45 degrees. So if you think about this circle here, for example, let me see if I've got a pen. I don't have a pen that's going to show up.
Nicole, are you asking about complementary and supplementary angles, the opposite angles? Yeah, we do that on two-dimensional, but it's a little harder on three. So go ahead, Kirsty.
Yeah, so picture, I found this 45 degree angle that's here, right? But now I'm also measuring, right? If I had something coming straight out, this other angle is being measured this way. So my two angles are in two different planes, right? So I have an angle that's being measured flat here, angle that's being measured. So I can't actually add them together to come up with what's left, because this angle here, this, let me see, change my color. Right, the angle here that you're asking about would actually be this axis here is 90 degrees to this. So this, what's left here would be 60 degrees. All right, so I could figure that out, although I don't necessarily need it unless I was going to be calculating an area. But because those two angles would be in the same plane, but the green angles and the yellow angles are in two different planes, so I can't add those together. Does that help?
It does, thank you.
All right, so just reminding you of all of the things that are available, and we want to really be emphasizing that on June the 6th, there's a switch that gets flipped in CC Connected between the 23-24 year and the 24-25 year. And so when that switch gets flipped, all of that 23-24 content goes away, and only the people who are both have enrolled and paid their tuition and have been marked as a member will have access to the Math Map materials on CC Connected, the full, the companion, and the digital lesson. So I just want to make sure we keep reminding people that some of that content is going to go away until you've been marked as a member in the portal. And then just continuing to remind you of the ways that we're here to support you. In the companion, again, we have these videos. These are videos that are on this front page here. So once you get in there, any of those videos, that'll help step you through how to use the companion. and that's where we have a lot more information in there, and we are slowly rolling out those lessons. They are going to be going live throughout the course of the year. And so right now we've got through lesson 7, I believe, is live. We have the forums. We have our curriculum assistants who are manning the forums and answering your questions. We have the book club here. And then again, that beauty of the math map is that we can all be working collaboratively with other parents and with leadership that has been equipped specifically for the math map. And everybody can email us. And so we've got a few minutes left. What other questions haven't been answered, or do you have? And they don't have to be from today. So this is your chance.
I have a more general question. I talked to my academic advisor and they indicated I should hop on and specifically ask Kirsty. I have an incoming Challenge A student, and I'm just wondering what the complex looks like for a child who has dyslexia and dyscalculia, and what this might look like if they have been traditionally behind in their math curriculums.
So I think that one of the beautiful things about the math map is that sense of being ahead or behind is maybe going to be, I don't want to say it's going to be erased, right? Because you're still going to have some kids that are in different domains, but I think it's going to give us a way to address students and not say, okay, well, because you don't calculate very fast, we're hindering you from still engaging with these concepts, right? And so instead, I think it's going to enable all of our students to participate in that conversation. There is an emphasis on language. And so when it comes to the reading of it, right, with the dyslexia, there's going to be a need to be attentive. But I think that the math map is going to give you space to be attentive to the language, where a traditional curriculum may not give you that same space. Because you're going to see it year after year, and because there's so much emphasis on learning the language of mathematics, instead of that being sort of an added burden to that student, to feel like, well, I'm supposed to be calculating over here, but I'm still decoding over here. I mean, a big part of what we're doing in the math map is just decoding and learning the language of mathematics. So whether that's working through the flashcards, whether that's the tracing, the copy work, the defining of the words, I think that actually is going to create a space for that student. I would say that being able to use the different domains. So you may have a student who, right, especially if their fine motor skills aren't maybe where you want them to be for the complex lessons, being able to say, okay, well, we're going to go back and we're going to pull some of these natural lessons or these fractions lessons in. There's ways that you can either replace all of the lesson pages with a different domain or half of the lesson pages with a different domain, that you're going to be able to customize for your student the pages that are going to work best for them and their needs, but yet they're still going to be able to be in community and have a common conversation with their peers. And so for example, in lesson 19, everybody's going to be talking about locations in 3D. And whether, we just looked at that example, whether they're in using naturals pages, fractions pages, or complex pages, they're all going to be able to say, well, there's 3 coordinates, and those 3 coordinates are R, theta, and phi. That they're all going to have that common experience that week. And so for students who perhaps have some learning challenges, I think that the math map is going to give them a way to participate in that conversation that they wouldn't have with other traditional curricula.
So maybe the examples you just went through are a good way to show what you're saying, Kirsty. So it doesn't matter which level you're in, you're going to do polar coordinates. And that's the thing that's going to take time for them to understand. that there's no ahead or behind. Go get what you need to learn the lesson. And that's what I mean, who here's ahead in their Bible studies? All right. So that's, another thing to remind them. You use the tools you need. And if they have learning disabilities, and we all have learning challenges, that might mean you use a slightly different tool. But we still need to, the example I just keep given is that you may be the one playing the triangle in the orchestra versus the violin, but you still need to be playing the same song with everybody else, even though the work you're doing may not be as hard as the violinist. And yet you still can be in community. And we're so intelligent and so gracious to work in community in everything except for like math and English and Latin. It's just been driven out of us. And so we have to reclaim how to help all levels at all times to keep on singing the same song.
Yeah. And those students who maybe the writing, right, may be a struggle, but they may, right, I mean, what they're going to see, right, they may be able to see patterns that other people miss, right, because they're so attentive. I mean, my brother had dyslexia, and so he worked harder for every book he read, and he's an avid reader, but he works harder than I ever will to read a book. But he can dissect a book and tell you the characters, the setting, what the author's style is. He'll see patterns in books. He gets so much more out of a book than I ever do. I admit it, right? I'll just flip through a book because I like the story. And so he sees things because he's had to train himself to be more attentive. And so I think that that's something that you may notice in the math map, is that those students who work a little bit harder, have to be a little bit more attentive, actually may get more out of the curriculum because they're going to start noticing the patterns, and they're going to start going, oh, like this is what this is, right? What about this? They're going to start asking questions and noticing patterns that students who are quick calculators are just going to go through and calculate, and they're going to miss, right? If they don't slow down and attend, they may miss some of the complexity that students who are working a little bit harder to attend may get.
Well, Kirsty, thanks for helping us sing the same song. We'll see you all next week. Bye.